So let's continue our discussion on DHCP server configuration. So the next step is DHCP scopes. So a scope is basically a pool of IP addresses and any other IP configuration parameters that you might need that the DHCP server is going to use when it leases IP addresses to clients. So a scope consists of the following required parameters. A scope name, so you have to have a name for the scope. The start and end IP addresses in a range. Usually your scope is going to be a range with a start and an end. There'll be a prefix length or a subnet mask, a lease duration, in other words, what's the default length of the lease that you're going to use. An exclusion range, so there's really a couple ways you can exclude IP addresses. You can do a de facto exclusion. So that means if you set your start point and your end point where there's either a block of IP addresses before the start or after the endpoint, or both, maybe you just set your scope to something in a middle range of IP addresses that are available on your network, then all of the IP addresses in the peripheral will be in a de facto exclusion. They won't be included in the DHCP lease. So you can manually set those as static IP addresses on servers, for example. So that's one way. You can also create an exclusion range. So you could say, here's my start and my end IP, but here's a range that I want to exclude. So you could do that as well. So you can create either a range. So you can either do it de facto by just making your start and your end, not include the IP addresses that you would not want to include in the leases, or you can explicitly define what that exclusion range is going to be. So you could do your start being at the very beginning of the network and the end being at the end of the network, and then or you can combine both of these. So you could have a de facto exclusion by defining maybe the first 200 IP addresses, but then maybe you realize that the .50 through .60 or something like that needs to be excluded, so you can create a range as well. So you can kind of do both at the same time. Another way you can prevent IP addresses from being utilized by DHCP for just any client is through a reservation. This is where an IP address is associated with a specific MAC address on the network. So every time the device with that MAC address does a DHCP request, they're always going to get back their reserved IP address. So the reservation has to be within the same subnet, and it has to be within that scope that we defined earlier in order for a reservation to work. You can't create a reservation in an excluded IP address. So some people make the mistake of thinking, well, I'll exclude the top 50 addresses because I know I'm going to do those statically, and then they try to make a reservation for those and it doesn't work because it's outside the scope. So you kind of have to decide how you're going to do this, whether you're going to assign addresses statically or if you're going to make reservations. What you can't do is try to, let's say you're going to use .50 through .60 for your servers statically, but you leave it in the included scope anyway, thinking, well, I'll just set those before they get handed out as IP addresses. That won't necessarily work. Sometimes it hands out those IP addresses even though they're already in use, even though it's not supposed to. And sometimes another machine will steal that IP address. So maybe you reboot that server, and for the couple minutes it's turned off, somebody does a DHCP request, and it happens to be the next one in the pool, and it gets that IP address, and now your server no longer has that IP. So it's a good idea if you're going to use reservations, you have to put those reservations in. If you don't want to use them, then you can certainly use exclusion. So if you are going to, once you create a reservation, then you could do an ipconfig release and then an ipconfig renew for the client to pick up that new IP address that you created for it. So you can get something you can force a machine to automatically get this new IP that you put in as a reservation. You can also kind of automatically set the lease to terminate on an IP address to force another machine to give up their IP address, although that's not quite as straightforward. Okay, so you can have multiple subnets and multiple scopes. So DHCP scope can service a single subnet. It is based on broadcasts, right? So broadcasts cannot traverse routers, so it's limited to just a single subnet. So there's three methods to handle multiple network subnets. You can configure a DHCP server in each subnet. That's one method. You can configure a single DHCP server with network interfaces connected to each subnet. In other words, you can use multi-homing, which we talked about previously in TCP/IP, and have the DHCP server straddle multiple networks. And you can also use relay agents, which we're going to talk about later in this unit. So we'll talk in the last part of the unit, I'll talk about DHCP relay. So here we have an example of a DHCP server that's connected to all three subnets. And then we have here a scope for each of those subnets. Again, because it's a broadcast-based protocol, you're limited to just a single subnet at a time unless you use a DHCP relay, which again, we'll talk about that soon. A split scope is a fault-tolerant DHCP configuration when you have two DHCP servers sharing the same scope information. So it allows both servers to offer services to clients. So that way, if one server goes down, the other one can take over. You can create these split scopes by using the wizard. So you install the DHCP server on both of your servers. You create a scope on the first server and you activate it. The wizard's going to configure the scope on the second server. So on the second server, you're going to run the wizard on the first server. The wizard creates the scope on the secondary server and creates the necessary exclusion range according to the split percentage on both servers, and then it creates reservations on both servers. So basically, you could create a split where different servers are going to respond. So that way, if you have a broadcast address, either one of the two servers can respond to that broadcast and start assigning IP addresses. That way, if one of the servers goes offline, you're still continuing to offer DHCP on your network even while something is offline. A superscope is a special type of scope consisting of one or more member scopes that allow a DHCP server to service multiple IPv4 subnets on a single physical layer. So it directs the DHCP server to draw addresses from both scopes. So it's useful if the number of computers on your physical network exceeds the size of the original subnet. So each scope that is part of a superscope is referred to as a member scope. There's some options in DHCP, and they can be assigned on the following levels. So server options affect all scopes, but can be overridden by a scope, policy, or reservation. So you have server level options, and then scope level options, and then policy options, which allow an administrator to assign IP address options to clients based on client properties. And then reservation options, which are based on a computer's MAC address, which we talked about earlier. And they take precedence over any conflicting options set at any other level. So anything at the reservation options level is going to take precedence over any of the options that you set on the other levels that are defined here. So some of the common options that you'll find at each of these different levels. So an NNN represents a 3-digit number that you're going to see. But basically option 003 is a router, 006 are DNS servers and DNS domain, and then 044 and 046 are WINs for WINs. So if you're running WINs, in other words, you can set these parameters in your DHCP server. So when somebody requests a DNS address, DHCP, in addition to providing them with an IP address, you can also provide them with the DNS information, with the WINs information, NetBIOS information. So all of that stuff can be handed back through DHCP. So pretty much everything they need for network connectivity can be handed back. And one of the ways to do that or set that is through these options. And again, you can set these options at those different levels, and they'll take precedence over each other as they go down that chain, starting at the server level and all the way down to the reservation level. So server options are configured by clicking the IPv4 or IPv6 node in the DHCP console. So you're going to click on it, then you're going to right-click on server options, and you can configure the options. So in the server options, you have a general list of options. In the upper pane, you have some advanced options, and then and you can see this is what it looks like. So you'll be able to go in here. So general options are the general DHCP options, and then you have that advanced tab. When performing DHCP server configuration tasks, right-click on the server node that you want to choose from the following tasks. So you have some tasks under for additional configurations for this DHCP server. You can add and remove a binding. You can back up your DHCP server. You can restore some additional tasks. You can delete, refresh, look at the properties, for example. Okay, so you can see here server bindings is which subnet we're connecting to. So in this case, it's bound to 10.10.1.2, but not bound to 203. whatever, which looks like a public IP address. So for DHCP server configuration, if you right-click on the IPv4 node, you can choose from some additional options. You can display statistics. You can create a new scope. You can create a new super scope, a multicast scope, configure failover and replication, which we talked about just a few minutes ago, define user classes and define vendor classes, and reconcile all of your scopes or set predefined options and properties. So this is a little bit what you'll see in that dialog. So for the IPv4 properties dialog box, you'll have 6 tabs: the General tab, DNS, Network Access Protection, Filters, Failover, and Advanced. So these are the tabs that you'll find. So General specifies statistics and logging parameters. DNS is how DHCP is going to interact with the DNS server, which is, of course, making updates, which we learned about in our previous unit. We learned about how DHCP can update DNS using dynamic DNS updates every time a new device is added to the network, for example. So this is where you configure that behavior. The network access protection, which enables or disables NAP on all of your scopes. Filters for configuring MAC address filters. So maybe certain MAC addresses aren't able to get DHCP. Configure failover or failover options, and then there's some advanced options that you can configure. And this is what that dialog box, of course, looks like. Pretty much looks like any other dialog box in Windows, right? So configuring scope properties. So the scope properties, so again, we started at the server level. We're working our way down. At the scope, you can set the general tab, DNS, network access protection, and advanced. Sounds familiar, right? So a lot of these settings are the same as from the server level, but these would override the server level. For example, if you enabled NAP at this level, but it was disabled previously, this would supersede that setting. And the DNS settings would, of course, supersede the settings that you set previously. We can also use filters. So DHCP filters allow administrators to restrict which computers in the network are leased IP addresses. So you can set up using MAC addresses. You can create a filter. So if you have an unknown MAC address or a MAC address that you don't want to do DHCP, you can add it as in the filters. For example, if you have a machine that you want to make sure uses the static IP address that you set, you could filter it so that if it does send a DHCP request, it doesn't get a response, so it forces you to set a static IP address. Filters are configured under either the IPv4 node, but they are not available for IPv6. So you can't do this in IP version 6, but you can do it in IP version 4. If you create an allow filter, only a device with a MAC address in the filter can lease an IP address from the DHCP server. And if you create a deny filter, all devices will be able to use DHCP except the ones that you put in the deny. So you can either have a whitelist or a blacklist. A whitelist meaning these are the only people that are allowed to use DHCP, and a blacklist would be these are the people that can't use it, but everybody else can. Obviously, using a blacklist is a little bit easier from an administrative perspective, but it's not quite as secure. Using a whitelist is obviously the most secure way to do DHCP, but it's an awful lot of work because you have to add all those MAC addresses manually. At that point, you might as well just start setting IP addresses manually. But you could also have some automated ways to manage those MAC addresses. DHCP policies give administrators fine-tuned control over the lease options. So you can specify one or more clients that IP address settings should be delivered to. Policy conditions can be created with a combination of things like the vendor class, user class, MAC address, client identifier, and the fully qualified domain name and the relay agent information. So policies can be configured at the server level or the scope level. So to create a policy, you're going to right-click Policies under the IPv4 node or the scope and click New Policy and start the DHCP Policy Configuration Wizard. And you'll go through these steps. So you'll give the policy a name and a description. Then you'll create one or more conditions that identify devices and then configure settings for that particular policy. And then you configure additional settings in the Policies Property dialog box after you're finished with the configuration. So basically, to kind of recap here what a policy is, you can set policies that affect only specific devices, and you can filter that based on the vendor class, the FQDN, or the MAC address, for example. And then once something is identified as being in sort of a pool of devices, you can put in a policy that changes some of the parameters that it receives from the DHCP server. Finally, let's talk about DHCP relay. So in some cases, you'll need to use a DHCP relay. This is if you have a large network and it's going to traverse multiple subnets, then you'll need a DHCP relay server that can communicate with the main DHCP server. So in other words, instead of, let's say we have we have 19 or 20 subnets in our network, it might be a little bit unwieldy to have 19 or 20 different DHCP servers. So, each with their own pool of IP addresses. So instead, we could configure one primary DHCP server, and then we have a relay agent in different areas of the network to handle those requests. It really doesn't work all that different from doing a standard DHCP request. Basically what happens is your server sends the DHCP discover broadcast message on its own subnet, and which would be in this diagram, that would be one of those two on the bottom, either the left or the bottom right. So it sends the broadcast. That the relay agent receives that broadcast and then sends a unicast message directly to the DHCP server that you see there at the top of the screen. That DHCP server will then, knowing that it came from that relay agent, knowing that it came in this case from, say, 10.1.2.1, for example, or 10.1.3.1, it knows which scope to pull an address from. It sends the response back to the relay agent, and then the relay agent does the broadcast on its own subnet. So basically, this works around the problem of having to use broadcast. We can use broadcast in a local subnet, and then that server will relay that broadcast message using unicast directly to the DHCP server that it knows about. So that's basically how it works. So this is just the process that I just described for you, but you can see here it's an 8-step process only because the DHCP relay has to accept each message either from the server or the client and relay that to the other side. So it's either receiving a unicast from the server and broadcasting it back to the client, or receiving a broadcast from the client and sending a unicast message to the server. What the relay agent does not do is it does not have its own settings for DHCP. It does not have scopes. It does not have settings or any of that type of thing. You're letting all of that stuff happen on the DHCP server from the enterprise level. All right. So if you're going to install a DHCP relay agent, you're going to do this in Windows 2012 R2. To install the relay agent, you're going to install remote access role. So it's a little bit different. You're not going to install DHCP. You're going to install the remote access server role and include the routing role service. With the routing role service installed in the routing and remote access console, you right-click on the server node, click Configure and Enable Routing and Remote Access, and then click Custom Configuration in the server setup, and then click the LAN routing checkbox, and next and then finish, and then click the Start Services when prompted. And in the routing and remote access console, you expand IPv4 node, right-click on General, and click New Routing Protocol. And then in the routing and remote access console, you right-click DHCP Relay Agent and click New Interface. In the DHCP Relay Properties box, accept the default settings and then click OK. Pretty straightforward, right? And then in the routing remote access console, right-click on DHCP Relay Agent and click Properties. So those are basically the steps to set up a DHCP relay server. And then when you're done, you click OK, and you'll have your DHCP server running. So again, this is all part of the remote access. So it's a little bit different. You're not doing this in DHCP. You're doing this in the routing and remote access role. But you don't actually have to do the routing and remote access. We're only going to use the DHCP portion if that's all we need. We don't have to do all of the other stuff with routing and remote access. So I think you'll find that at any enterprise network, you're probably going to need a DHCP relay unless you want to manage all of those subnets individually, which can be a little bit unwieldy. It's definitely good to have, just a few centralized DHCP servers handling most of these services. It certainly simplifies your life a little bit with DHCP. So in this unit, which was a relatively short unit, we talked about DHCP as part of the TCP/IP protocol suite. And then I talked about the process of the DHCP client requesting an IP address and then the DHCP server fulfilling that request. We talked about that 4-packet sequence, right? So the discover, the request, the offer. The discover, the offer, the request, and then the acknowledgement, right? So that 4-step process. We talked about how to install DHCP in Windows 2012. We talked about the scope and the pools of IP addresses within a scope. We talked about using a split scope for fault tolerance, so you can have multiple DHCP servers with their own portions of the scope. We talked about how you can provide, in addition to IP addresses, you can provide DNS server information through DHCP, and also that your DHCP server can provide dynamic updates to DNS. So every time a new client, for example, gets a new IP address, it can do those dynamic updates with DNS. We talk about some of the server options, which you can set from the DHCP console. We talked about some of the server configuration options, some of the IPv4 properties that you have available to you, so you can set those different options that we talked about with the 3-number designators. We talked about some of the filters you can use to restrict which computers can lease an IP address, which can be based on the MAC address, the vendor class, and so forth. We talked about some of the policies that you can use to fine-tune control of those leases based on some of these different parameters that we talked about. So not only could you restrict access, but you could also do DHCP, handle the behavior a little bit differently depending on what type of device it is. And if you're using Windows deployment services to install Windows OSs on computers, you might need to configure DHCP to respond to pre-boot execution or PXE boot because it needs to get an IP address before the machine actually starts up, which we didn't talk about too much, but that is discussed in your textbook. And finally, I talked about DHCP relay agent, which allows you to relay DHCP between different subnets so that you don't have to worry about broadcast being only propagated within a single subnet, and you can have a centralized DHCP server. And that concludes our unit about DHCP. In our final unit in this course, we are going to discuss virtualization. So we'll talk about Hyper-V, which is Microsoft Windows virtualization platform, and their hypervisor. And I'll go through a little bit about how that works. Sometimes a little bit difficult to do labs with it because our labs are in a virtual environment. So if you're using virtual machines within a virtual environment, it can be a little kludgy, but we'll certainly talk about virtualization. Virtualization's become very important, so I think it's an important topic for us to end this course on. Thank you for watching.